Welcome to our structural design series in Revit and Robot structural analysis. Okay, in this model, we want to further carry out the analysis and design of the model that we have sent, that has been imported from Revit structure. So as we can see that uh, this model is as a result of an analytical model that was brought from Revit to Robot and structural analysis professional. So I've created a quick checklist that will help us to just look at what that we need to do, the steps in analysis and design in Robot using analytical model from Revit structure. So we are going to follow this step, and I will drop the this material in the group so that you can always fall back on it if you have any issue. So the first step is for us to look at the setting. So we fix support on the model, we perform model verification to check any likely error. So if there is any error, we fix it. Then we move to group grouping of the structural members, group structural members. Then we define load type, perform load definition as application of load on members element. Then we move to performing manual or automatic load combination. Then we perform merging using panel calculation model. Then we move to the next. Now from that panel uh, from that merging using panel calculation model, we move to panel setting, which has to do with the adoption of load takedown slab using the two ways. Then we select finite element, and so these are basically the process that we are going to go through for us to be able to do all our design. So let's just go straight to the first step, which has to do with the setting. Okay, so when you send your analytical model to Robot, that is from Revit to Robot, the first thing you need to do is to perform some settings. So we go straight to perform setting. You go to tools, click on job preference. Now some of these thing is what we have already done as setting. So we might not, but I will just quickly take you through the process of how you can actually do your setting. So here you click on material. Okay, you start with the unit. You have to define your unit. So you click on unit, click on the dimension. So the structure dimension is going to be in meter. The section dimension will be in millimeter. Then section properties will also be in millimeters, and so on and so forth. Then reinforcement area will be in millimeters squared. Then crack width meter. So you move to force. So you also select your force. If you are going to use kilonewton per, your force will be in kilonewton. Then your moment, kilonewton meter. Then your stress, meganewton per meter squared. So these are the units that you need to work on. So it depends on the location. So you need to, you know, edit some of the units, and so that it will suit with your local environment. Then the next thing is for you to move to material. Now we are using hero code. If you want to make some modification, you can actually do some modification. So here I'm gonna change this name to steel A1. So I've already set this out. I've already set this. So the characteristics, strength of steel is 410. Then we have the reduction factor for shade to be 1.54. Then we have the limit strength for tension to also be 410, 410 megapascal. Then we have the for young mululus we have 200 megapascal. Then for share mululus we have this. For specific unit weight we have this. For thermal, so this you also allow this to remain at their default. But in the situation where you want to use maybe like 500 megapascal for the steel, then the young modulus will change from this 200 to 210 megapascal. So I don't want to touch anything here, so I'll simply click on OK. Then I'll click on save current parameter as default. I'll click on OK. I think those are the basic setting that I want to do. Okay, so after doing that, after you have finished doing the basic setting, the next thing you will do is for just running, is for you to perform a quick verification. Now, the reason for doing this quick verification is for you to check if there is any model error in your model, so that you can fix it at the initial stage your of your model. So this verification is very, very important. It's very, very important. It's very, very important. So let's just do a quick verification of the model. So a quick verification. So here we have numbers of warning is 1, numbers of error 0. Then why we have this warning is that there is no support. So this has given us an idea of what we want to fix right now. So I will click, I will close, then I will go to I will come here. Let me click here, then I will come to the base, click on the footing, then I will click on plan, then come here, click on here. Okay, so I want to insert the support right now. So I will highlight everything here. So when I highlight everything, I come to support. So I want to use fixed support. So I'll click on that, then I'll click on apply. I will click on close. So as you can see, the support has been fixed now. Okay, so we are done with that. So we can run another verification again. You can see that there is no error again. So we have numbers of error 0, numbers of warning 0. So we can now proceed. Okay, so the next thing we will do is for us to group our structural members. Very, very important. The reason why it is important for us to group these structural members, it can aid us when we are doing our design. So you can choose to design the column first. Then after you finish designing the column, you can design your floor beams. After designing the floor beams, you can design your roof beams and so on and so forth. So it's very important that you group these structural members. So to do the grouping, what we need to do now is to click on the structural element that that we want to group. So when you click on it, you right click, then you click on, you select similar. Now we are going to select by cross section. So by cross section, so you see that it has highlighted the similar cross section. So you come to this member selection. You come to member selection. So you click on member selection. So when you click on member selection, this dialog box will pop up. So you come to group. You come to group. So when you click on group, you click on this arrow that is facing down. You click on this arrow that is facing down. So this group definition dialog box will pop up. Then you can now define your column. So we can just call this one column. We can call this one CT1, meaning column type 1. So that is the name that we are giving to it. Column type 1. Column type 1. So you can now click on accept. Now, if you want to maybe add color to it, you can just come here. You can click on the color of it. You don't want to do anything in that way. You just want to label it, then move. So I can now close. Okay, so the next structural element I will group is the floor beam. Now, if you have been following us, you discover that the first floor beam and second floor beam has the same cross section. So we are using 225 by 450, 225 by 450 for both, except for the roof. So roof has 225 by, our roof have 225 by 300. So I want to group the floor beam. So I'll group this floor beam. And this grouping will also help us when we will be applying load definition on each of these members. It will be very easy for us to apply our partition load, whatever load that we want to apply on the structure. It will be very, very simple, very easy for us to do that. So this has been highlighted. So I will click on member selection. I will also click on group. Then I will come to this. I will now, so we can call this face and second floor beam. So we can use face and second floor beam. So you click on accept. Okay. So the next one is the roof beam. Next one is the roof beam. So you click on it. You come to select with similar cross section. So it has been selected. All the roof beam has been selected. You come to this. Do the same thing, group. Then come here. So we can call this roof beam. Call this roof beam. So we click and we close. So the next one will be the panel, that is the slab. So when you click on the slab, you right click, go to select by material. So you select by material. Now you come to member selection. Now when you are grouping your slab, you are not using member, you are using panel. You are using panel. So you have to take note of this. You are using panel. You are using panel for this. You are using panel for this. So under group, you come to this. So this will give us, we can call this slab, or we can call this floor slab. Okay. So we click on accept. We click on OK. So let's still run the verification again. Let's run the verification. So we still have 0 this. Then we click on this. Okay, so there is an error. I purposely did that so that we can look at the error. The error is saying incorrect value of young modulus for the material. Incorrect value of young modulus for the material. And what is the material? So the material here is the slab. So we are going to correct this before we now proceed with our design, with our model. We are going to correct it. So for you to correct that, for you to correct this, you click on geometry, you come to material, then you click on concrete. So when you click on concrete, you change concrete, the material, to 2025. So we change it to 2025. So you can use your control key, use this, click on this, then you click apply. Okay, so when you do that, the next thing is for us to go to our slab, because that is where we are having that issue. That is where we are having the issue. So we click here. So when we click here, it will take us to this dialog box will pop up. This dialog box will pop up. So when this dialog box pop up, so what we need to do right now is for us to define the material here. So as you can see, please, you have to be very attentive. As you can see, under material we have default floor. So the material for the floor has not defined properly. We have default floor. So this is where we are having that. This is where the problem of incorrect young modulus emanates from. So we come here, we click, we change the material to the concrete grade of 2025. So we now click on add. So the thickness with this label has already existed. Would you like to modify? Yes. So from here we can close. We can now apply. Okay, so it has been applied. So let's run this thing again and see if we will still have that error. So you can see that there is no error again. So we come to, let's go to verification. The cohesion of the calculation model has been provided by definition of this. So there is no error again. We have a little warning. So that was not really a problem. So we can now close and proceed. Okay. Now that we have done that, so the next thing is for us, we have defined we have grouped the structural members. We have run the initial verification, and we have been able to correct the error that is in the model. So the next thing is for us to define the load. So let me just open to my design template. So that we use that to define the load. Okay, so this is our slab design template. So I think in our previous video I've taken time to explain this, so I don't really have the time to explain that. So what really concerns us is this load computation for robot analysis professional. Now these load are on factor load. So here we are taking the slab load to be 150. So the slab load is 150 and the density of the concrete is 25. So here, robot will calculate the set weight. So we are not going to include the set weights in our load this thing, because robot is going to calculate it. But we are going to define the set weight. We will define the set weight and include it. But when it comes to load definition, we will concentrate on this. We will concentrate on the load on slab, which is the remaining part of the dead load, which is from here. Remember, when you look at this, we sum up everything here. Then at the end of it, we subtract 3.75 from this. That is why we have this 4.475. Then we will also consider the partition load. The partition load, which is this one times 3. 3 here is the height, that is the headroom. So this will give us 10.441. 10.41. Then we will also look at the live load. So by now, we should know where the live load is coming from. In my previous video, I've taken time to explain this, where all this live load is really coming from. Then we have the roof load. This is the dead and the live load for the roof. So this is the computation of the mortar finishes. This is where we have 0.6 that we add to the this 2.87 to give us 3.47. So okay, so for the load, let's go back to robot. We're going to define our load. So we go to load, click on load type. So we first of all define the load type. So we are going to remove everything here. Okay, so this will now be our set weight. So the set weight. So we are going to add the set weight, and that set weight is under dead load. Then the next one will be the dead load on slab. Now remember that these are all on factor load. Now why we are using on factor load is because when we will perform load combination. So when we perform load combination, that will be the stage that we are going to factor all the. So the software is going to do the factor, will bring in those factor of safety of 1.35 and 1.5 for dead and live load respectively. So that is why we are making use of this on factor load. So load on dead load on slab. So we go back. So this will be dead load. So just for us to divide dead load. Dead load on slab. Dead load on slab. So we add the dead load on slab. Then the next load that we are going to define will be the wall stroke partition load. So we go back to robot, and it is still under dead load. So wall stroke partition load. Wall stroke partition load. So we add. Okay, so under dead load we have the dead load on slab, we have the set weights, then we have the wall stroke partition load. So those are what constitute dead load on this structure. So after that, we move to live load. Okay, so let's go to live load. So you change this to live load. Okay, so for the live load, the first thing will be live load on slab. Live load on slab. So we add. So we add live load on slab. Then the next live load will be roof load. So roof load. So this fall under live load. It falls under live load. So we add. So we have gotten the dead load on slab. We have gotten the set weight, the wall stroke partition load, live load on slab, then roof load. So we have gotten that. So we can close. Okay, we can close. So after we have defined our load, define load type. So we have defined load type. So we want to perform load definition now. So the load definition is talking about application of load on member element. Application of load on member element. So that is what we are going to do right now. So we go back to robot. You click on load again. Click on load definition. This is where we are going to apply each of these loads. So when you click on load definition, you have to be mindful of the type of load that you want to apply. So I want to start with dead load on slab. Okay, so starting with dead load on slab, so I have to select dead load. I have to select this dead load under load type. Then after I have done that, I will come to member selection. So when I come to member selection, I will come to panel. Then I will click under panel, then under group, I will click on floor slab. Then I will click on this. So when I click on this, the entire floor slab is highlighted, which will now enable me to apply my load on it. So I will come under surface load. Then I will come here, then click on this. Then I have to define my load. Now let's go back and look at that load. So the load that we are going to use right now is going to be 4.47. It's going to be minus 4.47 because it's coming vertically downward. Minus 4.47. So we click here. Minus 4.47. So we click on add. We click on apply. So you can see that the load has been added to the slab. Okay, so we are done with that. We select the next load, which is the live load on slab. Since we are dealing with surface load for now, live load on slab. So live load on slab. So I will click on surface. I will check the magnitude for the live load on slab. So live load is 2.25. 2.5. So I will click here, minus 2.5, minus 2.50. Then I will click on add. Click on this. So the load is added. So we are done with the surface load. So the next thing, we move to wall stroke partition. Wall load stroke partition. So to apply this wall load stroke partition, we need to select those elements that the load will be applied on. So you click member selection, you click on group, then you click on first and second floor B. Then you click on this. To highlight the entire structural member. So after that you come to load definition. Now this is going to be a member load. So you click here. It's going to be a member load. So we are applying wall stroke partition load, which is 10.41. 10.41. So you click on this, you click on apply. So it has applied. So we will stop this model here because we don't want the video to be too long. So we see you in the next model.